So let's take a look at box plots. So these, in my opinion, tend to be the harder graph to look at. It's not as obvious when you're looking at the data, what the data values are. So first we're going to build our own box plot. You're not going to be assessed on that. You're going to just be assessed on analyzing it, but I think it's going to help to understand how we analyze after we've built one. So box plots uses a number line to show the distribution of a data set by using the median and the Q1 and the Q3 values. Actually, no, we're going to do Q1 and Q3 and extremes. So let's just first look at how we would make a box plot. So first thing we would do is we are going to find these different values, the extremes, the Q1, the Q3, and the median. Well, we know when we're finding the median and the quartiles that we have to put it in order from least to greatest. So that's what I'm going to do first. I see 65. I see 67. I see 3 68s. I see a 72, and I see a 74. So now for putting these in order, I'm going to cross off lowest, highest, lowest, highest, lowest, highest. I have two values in the middle, but they are the same, so my median is going to be 68. Now I'm going to find my Q1. So on my bottom half, I'm crossing off lowest, highest. I'm left with two values in the middle. They are the same, so that means that my Q1 is 67. And then I'm doing the same thing to the top. Crossing off lowest, highest. I'm left with two values in the middle. They're different. So I'm doing 68 plus 72, and dividing that by 2, and I'm going to get 70 for my Q3. Then my extremes are new. So we've got a lower extreme, which is just saying what is our lowest value here, which is 65. And then we've got our upper extreme, which is saying what's the highest value, which is 74. So we've got these five values, 65, 67, 68, 70, and 74. I'm going to plot those as dots above the number line. So 65, I'm putting a dot above the number line there. 67, putting a dot above the number line there. 68, putting a dot above the number line there. 70, I'm putting a dot above the number line there. And then 74, putting a dot above the number line there. So the box plot can also be referred to the box and whisker plot. We're going to have a box, and then we're going to have lines that come out from it. The second and the fourth dot, I'm going to make into the sides of the box. So I'm going to do a little vertical line and then connect them so it makes a box with the dot in the middle. That dot in the middle should be the median. That's our middle value of 68. I'm going to draw a line through it. So it kind of breaks our box in half. Then for the bottom dot, my lower extreme, I'm just going to connect with a horizontal line. And same thing on the right side. So what it's actually kind of done is we split our data into 4 pieces. We have this first portion right here, which kind of represents these 2 values. We have the second portion right here, which represents these 2 values. We have this third portion right here, which represents these 2 values. And then last but not least, we have this portion right here, which represents these two values. So if we look at it here, it's easy to see that we split it into 4 equal parts. 2 values, 2 values, 2 values, and 2 values. When we look at it in our chart, it doesn't look like 4 equal parts because they're spread out differently. This is really far apart versus this box is really close together. So what the reason is because even though they each contain 2 values, some of them are closer to each other than others. So 65 and 67 are 2 apart. 67 and 68 are 1 apart. 68 and 68, this was 70, because that was our median value. So 68 and 70 are 2 apart. And then 70 and 74 are 4 apart. So even though it's split into 4 equal parts, they're more spread out just depending on the values. But since they are split up equally, they each represent 25% of the data. They are a fourth of the data. So we're going to be using that to kind of analyze. So let's look at this just in an example that's written out, and then we're going to observe again. So as I said, since we split it into 4 equal parts, it each represents 25% of the data. So we have this first part right here, the line on the left, that is 25% of the data. Then we have our second part, which is the left side of the box. That also represents a fourth of the data, 25%. Part 1, part 2, then we are going to be looking at part 3. I'm going to highlight that in green. Which represents 25% of the data. And then the last part, even though it's small, that still represents 25% of the data. So we have 4 parts: the line, the left side of the box, the right side of the box, the right line. Our first point is our lower extreme. Second point is the lower quartile. The line in the middle of the box is the median, which makes sense. The median splits it in half, and 25% plus 25% is 50% on the left. 25% and 25% is 50% on the right. Then we have our Q3 and our upper extreme. So now let's look at analyzing these different values. A restaurant recently collected data to see how many minutes their guests waited for a table. The data is presented in the box below. Use the plot to answer the following questions. So first off, I'm just going to pick out these numbers. So my dot on the left, it's in between 14 and 16, so the lower extreme is at 15. My Q1 is the dot on the left side of the box, and that is at 24. My median is the line in the middle of the box. That's in between 28 and 30, so that's at 29. My Q3 is the right side of the box. That's in between 32 and 34, so that's at 33. And then the last dot is my upper extreme. That's in between 34 and 36, so that's at 35. So I'm just going to go ahead, just like I had been doing, and highlight the different portions. I've got part 1, which is my lower extreme to my Q1. I've got part 2, which is my Q1 to the median. I've got my part 3, which is my median to the Q3, and my part 4, which is the Q3 to the upper extreme. Then I'm going to actually calculate the value. So either I can kind of count on the number line here and go, okay, I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9 to say that this is a difference of 9, or I'm just going to subtract. You can use a calculator. My Q1 is 24 minus my lower extreme of 15 gives me a distance between the two of 9. Same thing for this blue box. I can count from 24 over 1, 2, 3, 4, 5 to say that it's a distance of 5, or I'm just finding the difference between my Q1 and my median. So I can do 29 minus 24, which is 5. For the green box, again, same thing. I can count 1, 2, 3, 4. I'll kind of circle these so they're easy to see. Or I'm doing my Q3 of 33 minus my median of 29, which equals 4. And the last one, counting 1, 2. Or that's my upper extreme of 35 minus the Q3 of 33, which equals 2. You might be able to visually see it too. You can see where it's more spread out and where it's close together. So where it's the most clustered, if it helps you to think of clustered and close together, that's going to be our smallest range, which is the 2, and that was in between our Q3 and our upper extreme. For what range are the data the most spread out? So we're looking for the widest range, which you can kind of clearly see here, but it also has the biggest number spread, which is 9. That's between our lower extreme and our Q1. What is the IQR? So we're doing our Q3, which was 33, minus our Q1, which is 24. You can plug that into the calculator, and you get an IQR of 9. What percent of people had to wait over 29 minutes? So I'm going to do a different color here, but remember, each portion is 25%. So 25% here, 25% here, 25% here, 25% here. So when we're looking at waiting over 29 minutes, that means bigger than 29. So I'm going to find 29 on my plot. It's kind of hard to see, but 29 is right here. So how much is higher? Well, we have 25% plus another 25%, which equals 50%. What percent of people had to wait less than 24 minutes? So same thing, I'm going to find 24 on here. I see 24 right here. Less than means lower than, so I'm looking to the left. All that I see is a 25%. So it's just 25% that had to wait less than 24 minutes. Let's look at another example. The number of goals scored by Blackhawks players in the 2012-2013 season is shown in the box below. So again, first I'm just going to point out my values. So we have our lower extreme is here, Q1, median, Q3, upper extreme. So my lower extreme is at 3, my Q1 is at 6, my median is at 8, my Q3 is at 14, my upper extreme is at 23. Then I'm going to look at my different ranges. So I'm going to highlight this range, highlight my next range, highlight the third range, and highlight the fourth range. Again, either you can count, okay, this is 1, 2, 3 apart, or I'm just subtracting. Q1 minus our lower extreme is 3. The next range, our Q1 to our median, I can count 1, 2, or I can subtract my median minus my Q1. 8 minus 6 is 2. Next up, we're doing the median to the Q3. So I can count 1, 2, 3, 4, 5, 6. Or I can subtract my Q3 of 14 minus my median of 8 is 6. And the last range I can count, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I can subtract my upper extreme of 23 minus 14. It also may be easy to just spot. Remember, clustered is close. So our smallest one, which these two look like it, and specifically the 2 is smaller. And that's between our Q1 and our median. For what range are the data the most spread out? So that's our widest range. That's this range right here of 9, which is our Q3 to our upper extreme. What is the IQR? We're going to take our Q3, which is 14, minus our Q1 of 6, and we get an IQR of 8. What is the range? We're going to take our highest value, that upper extreme of 23, minus our lowest value, our lower extreme of 3. 23 minus 3 is a range of 20. And then what percent of Blackhawks players scored at least 14 goals? So at least, if you look at kind of our keywords, means greater than or equal to. So I'm going to find 14 on here, which is right here. I'm going to remember, this is 25%, the blue is 25%, the green is 25%, the yellow is 25%. So looking from the 14, at least it's greater than or equal to, I only see 25% is greater than. What percent of Blackhawks players scored less than 8 goals? So less than 8 goals, we are looking at where 8 is. Less than means smaller than, so I'm looking at what's less than. I see 25% plus another 25%, which equals a total of 50%. All right, let's look at 2 more. Okay, interpreting a box plot again. Below is the average number of minutes students at Hawthorne Middle South spend on homework each night. So I'm identifying my different parts. Lower extreme, Q1, median, Q3, upper extreme. My lower extreme is at 10, Q1 is at 15, median is at 21, Q3 is at 25, upper extreme is at 35. Looking at my different ranges, I'm going to highlight them. And finding those distances. You might be able to easily look at it, but let's find the difference. So you can either count 1, 2, 3, 4, 5, or subtract. Q1 minus lower extreme is 5. Next one, Q1 to median, I can count 1, 2, 3, 4, 5, 6. Or I can subtract my median minus my Q1. 21 minus 15 is 6. Next range, median to Q3. I can count 1, 2, 3, 4, or I can subtract my Q3 of 25 minus my Q1 of 21 is 4. And the last range, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or I can subtract my upper extreme of 35 minus my Q3 of 25. So most clustered, again, is the close together. So it's our smallest range, 5, 6, 4, 10. 4 is the smallest range, which is our median to our Q3. And for what range is it the most spread out? So our widest gap is the yellow part here where the 10 is, Q3 to upper extreme. What is the IQR? We're going to take our Q3 of 25 minus our Q1 of 15. 25 minus 15 is 10. What percent of students spent over 21 minutes? So over means greater than 21 minutes. So remember, this is 25%, 25%, 25%, 25%. I'm going to find 21 on here. I see it right here. Over is greater than, so I see a 25% and another 25%, which equals a total of 50%. And then what percent of students spent at least 15 minutes on homework? So at least means greater than or equal to. I'm going to find 15 here. We're looking to the right because it's greater than or equal to. I see 25% plus another 25% plus another 25%, which equals a total of 75%. All right, last one before trying this on your own. The daily temperature in Alaska in January is shown in the box plot below. So I have my lower extreme, my Q1, my median, my Q3, my upper extreme. So my lower extreme is at 5, my Q1 is at 6, my median is at 8, my Q3 is at 12, my upper extreme is at 19. Looking at our ranges, I'm going to highlight the different parts. So I've got my first range, my second range, my third range, and my fourth range. So now I'm going to be looking at the distance between those. So I can count. That's a distance of 1, or I can subtract my Q1 minus my lower extreme. 6 minus 5 is 1. The next range, I can count 1, 2 across, or I can subtract my median of 8 minus my Q1 of 6 is 2. Next range, I can count 1, 2, 3, 4, or I can subtract my Q3 of 12 minus my median of 8. And the last one, 1, 2, 3, 4, 5, 6, 7. Or I can subtract my upper extreme of 19 minus my Q3 of 12. So clustered again means close. So our smallest range, 1, 2, 4, and 7, our smallest range is 1, which is our lower extreme to our Q1. Where is it the most spread out is going to be our largest gap, which is this yellow one here where it's 7. That's our Q3 to our upper extreme. What is the IQR? We're going to take our Q3 of 12 minus our Q1 of 6. 12 minus 6 is 6. What is the range? We take our highest value of 19 minus our lowest value of 5. 19 minus 5 is 14. And then what percent of days was the temperature at least 8 degrees? So the word at least tells us greater than or equal to. Remember, this is 25%, this is 25%, this is 25%, and this is 25%. So at least greater than or equal to 8. So I'm going to find 8 on here. Greater than or equal to is to the right. So we've got a 25% and another 25%, which equals a total of 50%. And then what percent of days was the temperature less than 6 degrees? So less than means it's going to be smaller than, it's going to be to the left, so I'm going to find 6. And I'm looking at anything that's less than, so I'm looking to the left, which is just 25%.